Alright, so what's up guys? If you've got one of these mini lathes, whether it's Harbor Freight, Beaver, or whatever, I think they're pretty much all the same in the sense that the the spindle, the through hole through the spindle, just dumps anything that passes through the spindle, chips or whatever, is going to fall straight onto the gearbox here, and the cover is no help. It'd be nice if the cover was sunk in past this, and then any chips that came out of it would just fall on the outside of the cover, but that's not the case. So instead of just sticking a piece of foam in there or paper towel or something, I'm going to try to make a little plug, basically kind of like a collet. So we're going to turn the OD down a few thou bigger and come back here and make us a smaller diameter behind, so we'll leave kind of like I'm blanking, larger diameter out here on the front, and then we're going to split it like a collet, and hopefully we can just pop that in, pop it out if we need to pass something all the way through, or pop it out to clean stuff out, and that'll keep any chips or any material from working their way through the spindle while you're machining and landing on the gearbox, which would not be ideal. So let's get started. I've already took a facing cut. I've got some type of plastic. I couldn't tell you if it's Delrin, Peak, whatever it is, but it's plastic. My spindle bore, it's pretty rough in there, but best I can tell it's about 812 thousandths. So we're going to machine this down. We're currently at 1 inch 3. I haven't made myself a print or nothing. I'm just gonna be doing it off what looks good to the eye. I could use the power feed, but I'm not going to be turning this back very far, so it shouldn't really matter. Alright, I've gotten it down to where I need to just take 7.5 more thousandths off to be above the ID of the spindle bore by the amount I want. Doesn't really matter with plastic, but I kind of want a decent finish, so I had just been roughing that down by moving the carriage. This time I'll use the compound, which I've got set parallel to the ways, and get a little bit smoother finish. Check her diameter. .824, 812's the bore. Alright, so we're good with that diameter. Go ahead and break our edges, not like it really probably matters. We'll come back maybe 100, 150 thou, something like that. Plunge in. Alright, I probably don't need to bother with a center drill, but my 1/2-inch drill bit that I was going to use is very long, so for the heck of it, we'll use a center drill, get us a spot in there to start with, just to make sure that drill doesn't walk. Although again, really don't think it even matters, especially in plastic, but we'll do it anyway. Which it's going to end up being, the left side of it's going to end up being further back here. So I'm just going to mark a flute on my drill. There's no need to be precise with it. Way too much speed. So we'll just feed this in till we hit our red line. That is close enough. All right, so now what we're going to do, I'm simply going to take this out. I'm going to put a little chamfer on the ID there, just for the heck of it. Really no need for it. But we're going to take this out, and I'm going to slit it into 4 sections with a hacksaw down to close to the shoulder, and then we'll test fit it, and then if it works, we'll stick it back in the chuck, part it off. Alright, we got it slitted, kind of like a collet. Use the knife, deburr the outside, run the 1/2-inch drill back through the ID, deburr the inside a little bit. Moment of truth. Negative. Oh, perfect. Tight fit too. Actually, I might turn this back so it's a little shorter, but at least this way I've got something to hold on to, grip it with. Slide it in. Let's see what it looks like with the cover on. Alright, so there she is with the cover on. Got a little run out to it. It doesn't hit the cover anywhere, so that's pretty good. And then that's enough that I can grab it, pull it in and out, hopefully. That way I don't have to take the cover off to be able to grab this, just take it in and out if I need to pass a long piece of bar stock through there. So, we'll see how long that holds up. I'm going to also, in the event that it's this long and it manages to somehow work its way out of that spindle, it should fall out. Granted, it'll be spinning a few hundred RPM, so it may fly off in the air, but it won't end up landing on the gearbox. So that's a happy accident that the piece of stock I started with was this long. So put us a little chamfer slash radius on it on this side. There's a bit of a tit on it. I'm not worried about facing it. Good enough. So stay about 15 thousandths bigger right here on the towards the face than the idea of your spindle. Undercut a little bit, leave it about an inch, inch and a half long. I can actually, it's got a tight enough bite I can actually spin the spindle with it, so hopefully that works. Doesn't ever fly out. And that way, if you're cutting something that makes an absolute mess with chips, brass, plastic, anything like that, and you're not up against the face, some of them chips, or if you got like the first job I did, cannulated bronze, so I was getting tons of chips through the spindle, so I was constantly having to blow out and keep an eye on whether or not my chips were ending up in my gearbox, which would not have been good. So quick, easy little project, keep you from destroying them plastic gears, or at least hold it off, make it happen a little later rather than a little sooner. So